Hi guys, let's do valid parentheses. So we're given a string S containing just these characters, and they want us to determine if the input string is valid. An input string is valid if the open brackets are closed by the same type of brackets and the open brackets are closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So if we look at these examples down here, and when the input string is this, we output true because this open parenthesis is closed by a corresponding closed parenthesis. And then in example 2, we output true because each type of parenthesis here is closed by the same type of closing parenthesis. In example 3, we output false because this parenthesis is closed by a square bracket, so these are mismatched. And in example 4, we output true because the square bracket is closed by the corresponding square bracket and the parenthesis is closed by the corresponding parenthesis. So to do this, we're going to want to loop through the string and check each character at each index of the string, and we'll push each character onto a stack. So I'll start with this example here. So let's say we have a stack, and I'll label the indices of our string. So if we are at index 0, this is an opening parenthesis, so we can add that to our stack. And then when we get to the index 1, this is a closing parenthesis. So because it's closing, we're going to check our stack to see if we have the corresponding opening parenthesis at the end of the stack, and we do. So we're going to remove this and continue along our string. So at index 2, we run into an opening square bracket, so we're going to add that to our stack. And then at index 3, we have a closing square bracket. So because it's closing, we're going to check if we have the corresponding opening parenthesis, and we do, so we can remove that from our stack. At index 4, we have a opening curly brace, so we're going to add that to our stack. At index 5, we have a closing curly brace, so we check our stack for opening curly brace, and we have that at the top, so we remove that. And then now we're at the end of the string, and our stack is empty, so we can go ahead and return true. So let's try this again with example 4. So in this example, we have 4 characters. Okay, so we're going to loop through the string. At index 0, we have an opening parenthesis, so we're going to add that to the stack. Then at index 1, we have an opening square bracket, so we add that to the stack. At index 2, we have a closing square bracket, so we check the end of the stack for a closed square bracket, and we have that, so we can remove that from the stack. And then at index 3, we have a closing parenthesis, so we check our stack for a opening parenthesis, and we have that, so we can remove that. We're at the end of the string, our stack is empty, so everything's good, everything got matched, and we return true. So I'll do one more example with one that does not work, so we would return false. So when we loop through this string, at index 0, we have an opening parenthesis, so we pop that to the stack. Index 1, we have a closing square bracket, so we check for an opening square bracket, and we don't have that, so we just return false. So basically, every time we encounter an opening parenthesis of any type, we're going to want to add that to the stack. And then anytime we encounter a closing parenthesis of any type, we're going to check the top of our stack for the matching opening parenthesis. And if we do have it, we remove it. If we don't have it, then we have an issue there. So to keep track of the mappings as well, so like this type of parenthesis must match up to this type of parenthesis, and the square bracket must match up to this square bracket, and so on, we can build a hash map. So just mapping each character to each other character. And you don't have to use a map, you can just also check for if the characters themselves, but I'm just choosing to do it this way, so it's really up to you. And then we're just going to add each of our mappings. Okay, and then we're going to initialize our stack. And then we're going to loop through our string. Okay, and then for each character, so let's go back to like example 2, one that does work. So our character C currently is this opening parenthesis. So we're going to add that. So, well, first we're going to check if our map contains this key, because that means it's an opening parenthesis, right? Because our map looks like, oopsie, sorry. Our map looks like this. So we're going to check if our map has the key, which means it's an opening parenthesis. Okay, and then if it does, then we're going to add that opening parenthesis to our stack. So then now we have this. Okay, and if it does not have that key, then either so then it needs to be a closing parenthesis actually, because it only contains these characters. So if it's a closing parenthesis, then we're going to want to check if, well, first of all, if our stack is empty, then we also have an issue, right? Because if this is empty and we are here, for example, then we don't have a matching opening parenthesis, so that's a mismatch, so we're going to return false. So if our stack is empty, return false. Okay, and then if our stack is not empty, but it's also not an opening parenthesis, it must be a closing parenthesis, so we're going to check for the top character in the stack. So we can pop the top character, and then if our map's value of the, so like, let's say we're here, right? Then our stack should have this, right? So we're going to get the value of this in our map. And if that's not equal to our character, so like here, right, then the top character in our stack is this. And then if we check our map, then that maps to this character. If that is not equal to the character that we are at, then we're going to return false because that's a mismatch. And we're just going to do this for everything in the entire string. If we reach the end and we have no issues, then we're just going to check lastly if our stack is empty. Because once we reach the end, then if everything matched up correctly, our stack should have nothing in it. So then we'll just return if the stack is empty. Forgot to comment that out. Okay, and then, so our time complexity is O of n, where n is the number of characters in our string s, because we iterate through the string once, visiting every character in the string once, right, no matter what. And that's our only loop here. And then our space complexity is O of n as well, and n is the same thing. Because, so our hash map is actually not, like, I think it's like constant because we put a constant number of characters in here, so that doesn't really matter. But our stack is really where it matters because our stack, worst case, is going to store n characters. Like, if this was like a complete mismatch, like example 3, then we're going to add both of these characters into our stack, and then at the end, we're not removing any of them because there was no matches, so the stack is storing O of n characters, basically. So then that's why this is O of n. And that is our only other data structure. So that's it for this problem. Thank you guys for watching, and let me know what I should do next. Bye.